So hello everyone. Well, I'm Camila, your ANSYS lead, and Brian.
Yeah, I'm Brian, the other ANSYS lead.
So this is our second lesson for ANSYS, and today we're gonna be showing you how to do a flow over a flat plate. And wait, okay. So we open Workbench, and then we're gonna go to Fluent, which is here, and then we're gonna create a new project. So our first step is always the geometry. So we're gonna right click and we're gonna select new design modeler. It's loading. Okay, so here we are. We're gonna select the Z axis point of view. Then we're gonna click sketch. And for this, we're gonna click rectangle since we're gonna do the plate. And we're gonna start from the origin to sketch. And now we're gonna change the dimensions. We're gonna click dimensions, general, this, vertical. And now for this, we're gonna put the horizontal dimension to be 5 meters. And then vertical 0.5. And now for the domain, we are gonna create a really big rectangle. That is where our actual flow is gonna be in. So, wait. And now we're gonna do the same thing. We're gonna go to dimensions again. Horizontal, then vertical. And now for the horizontal, we are gonna put 70. And vertical gonna be 50. And now we're gonna adjust it to be more symmetric. So we're gonna select horizontal. And we are gonna put from, let's do from the y-axis to the final part of the rectangle. And now we're gonna put it to the, this part we want it to be longer so we can see the effect of the flow going after it passes the plate. So we're gonna see like a wake region and all of that. So we're gonna put it to be let's say 50. And now we're gonna do the same thing but for the vertical. So we're gonna get vertical, and now we're gonna select from the X to the side of the rectangle. Wait, no, never mind. I did that wrong. So X-axis here. There we go. I don't know what I did. And this was how much? 50. So we're gonna put this was 25. There we go. So now it's more symmetric. So we're gonna go to, we're gonna see concept, surfaces from sketches. And we're gonna select, where's the sketch? There we go. So select the whole sketch, now apply, and then we're gonna click generate. So now we have our surface created, and this is where we're gonna analyze the flow. So then we're gonna go back to Workbench. And we're gonna go ahead and create the mesh. There it is. Mesh, what is it? Do you see it?
I still see the design modeler.
Okay, great. Oh, design model?
Yeah.
Let me change it.
Yeah, now I can see the meshing section.
Okay. What is happening? No. There we go. So here our first step is gonna be to click on Insert Automatic Method. We're gonna select Apply. So here we're gonna keep it all the same and then generate. Now this does not look that good, so we're gonna click Mesh here, and then we're gonna see on this menu where it says element size, we're gonna reduce it to 0.5. Here, wait, sorry. So yeah, we need to select this and then click that, and now generate. So this will give us a better mesh, like more detail with a lot of more nodes. No. So this is after it did after we change the element size, so we can see it looks better, but now we want to make it even better, so we're gonna add a refinement. So right click insert, and then we're gonna go to refinement. So we're gonna select the whole thing, apply. What? Yeah, never mind. And now we're gonna change this to 3. And then generate. So this will give us a more detailed mesh, like more refined, which is better for our calculations. So this is how the mesh looks after we did the refinement. So we can see it's a lot better, like more detail. And the next step will be to create the naming of each edge. So very important to select the front edge and name it inlet, and then the back one outlet, and then the top and bottom symmetry, and then for the walls we don't really care that much how we name it. So I just put like top and bottom wall, and then the inlet wall and outlet wall. So this will finalize our meshing. And so now we're gonna switch to Workbench. And we're gonna right click mesh and then update. But right now we're gonna go to setup. So this is the same one, it's just finished. So to make it faster, we're gonna go to setup, which is our next step, which is here. Yeah. So for this one, we want to see how it flows. Like we're gonna create a laminar flow, but we're gonna, instead of selecting here laminar, we're gonna select K epsilon, and we're gonna
go. By the way, we cannot see the screen.
Oh no? Oh, okay, never mind.
You're still on the workbench.
No?
Yep, you're good.
Okay, good. So wait, let me go back. So for this one, we're gonna go to here and change the model. Instead of laminar, we're gonna select K epsilon. And then on this menu, we're gonna select enhance wall treatment, and here we're gonna select pressure gradient effects. So I'm gonna click OK. And materials, we're gonna select air. Our density, we change it to 1, and then viscosity 1.25 times 10 to the 95. So all of this we change the numbers to create our Reynolds number to be laminar. And then boundary conditions, we make sure that our inlet has the velocity that we desire, which is 10, I think. What's the measurement? Low. Okay, yeah, 10. And then outlet, we just want to make sure that it's pressure outlet and set to 0, but it should be. Yep. And the rest, we don't worry about it. So then reference values, I'm gonna check that everything is how we want it. So yes, now click here, initialize, which we already did. So it's all done here. And now run calculations. We run it already, so it should be fine. So now we're gonna go and show results. Okay, so here we want to see first, we're gonna show you how to create, well, the velocity contour, which is this one. So you click here on contour and now you create a new one and then you name it velocity and then click OK. And now here's where you select where you want it. So it will be a whole surface. And where am I? Should be here. Yeah. So velocity. And then number of contours, we always want it to be 50. So this is what it's going to show, and we can see the boundary layer here, the stagnation point in front of the plate. Here is where the velocity is going to be 0, the maximum velocity right here. And now we want to show you pressure. So for the pressure, on the stagnation point will be the maximum, and now around will be decreasing. And now we can see in the back, this will be like the wake region right here, where there's like almost, the pressure is really small. And yeah, everything looks good. Now,
Yeah, just a little closer.
all right, so yeah, I guess this will be all. I hope you enjoyed this lesson, and just make sure to, if you have any questions, just message us on Discord. And well, I just hope to see you all next Friday. So take care.